Hey guys, and welcome to another video. Today I'll be showing you how nuclear weaponry is made. Please leave a like and subscribe if you haven't already, and let's get straight to it. All matter is composed of atoms, incredibly small structures that house different combinations of three particles, known as protons, neutrons and electrons. At the centre of each atom is a nucleus, the plural of which is nuclei, where neutrons and protons are bound in close proximity together. Most nuclei are relatively stable, meaning the makeup of their neutrons and protons is comparatively static and unchanging. During fission, the nuclei of certain heavy atoms split into smaller, lighter nuclei, releasing excess energy in the process. This can sometimes occur spontaneously, but can also, in certain nuclei, be induced from outside. A neutron is shot at the nucleus and is absorbed, causing instability in fission. In some elements, such as certain isotopes of uranium and plutonium, the fission process also releases excess neutrons, which can trigger a chain reaction if they're absorbed by nearby atoms. Fusion works in reverse. When exposed to extremely high temperatures and pressures, some lightweight nuclei can fuse together to form heavier nuclei, releasing energy in the process. In modern nuclear weapons, which use both fission and fusion, a single warhead can release more explosive energy in a fraction of a second than all of the weapons used during World War II combined, including Fat Man and Little Boy, the two atom bombs dropped on Japan. All nuclear weapons use fission to generate an explosion. Little Boy, the first nuclear weapon ever used during wartime, worked by shooting a hollow uranium-235 cylinder at a target plug of the same material. Each piece by itself was not enough to constitute a critical mass, the minimum amount of nuclear material needed to maintain fission, but by colliding the pieces, critical mass was reached and a fission chain reaction occurred. Modern nuclear weapons work slightly differently. Critical mass depends on the density of the material. As the density increases, the critical mass decreases. Instead of colliding two subcritical pieces of nuclear fuel, modern weapons detonate chemical explosives around a subcritical sphere or pit of uranium-235 or plutonium-239 metal. The force from the blast is directed inward, compressing the pit and bringing its atoms closer together. Once dense enough to reach the critical mass, neutrons are injected, initiating a fission chain reaction and producing an atomic explosion. In fusion weapons, also called thermonuclear or hydrogen weapons, the energy from an initial fission explosion is used to fuse hydrogen isotopes together. The energy released by the weapon creates a fireball that reaches several tens of million degrees, temperatures in the same range as the centre of the Sun, which also runs on fusion. So, to recap, modern nuclear weapons work by combining chemical explosives, nuclear fission and nuclear fusion. The explosives compress nuclear material, causing fission. The fission releases massive amounts of energy in the form of X-rays, which create the high temperature and pressure needed to ignite fusion. And that concludes today's video. Thank you so much for watching, remember to subscribe, and see you in another video.